we're not even aware of per se as the limits of our own intelligence. So if you have different forms of intelligence, then we might see things that we currently cannot. And I think that that's a tool that is a real game changer.
We are the product of our explorations. Exploring the future of intelligence may be our greatest one yet.
The brain does a lot of stuff behind our back, as it were, or without our knowledge. And that's what yields our intelligence. And if we can really map these brain circuits and understand how information is flowing and being processed within them, that might really allow us to not only have insight into human intelligence that would allow us to build better artificial intelligences, but frankly, we might want to implement these computers using brain cells.
Your brain consumes less than 30 watts of energy to do its computation, and it does better computation than a supercomputer does, which takes 24 megawatts. Now, as more and more people are being pulled out of poverty, many people are going to require this computational load. So how are you going to satisfy that? The clear candidate for doing that is neurotechnology, or using neurons for it.
The reason I'm going to build a biocomputer is to implement logic in places where no existing computer works. And a little bit of logic in new places is worth a lot of value and a lot of good. How come in 2016 it's still the case that people can't tell whether or not there's lead in their drinking water? We already have in nature genetically encoded sensors that detect the presence of lead.
Right? So biological cells sense other biological materials. Now imagine if you could marry the wetware, which is the brain, if you could marry that with the existing software, the power that can be delivered from that is really exponential. People that have asthma, for instance, we could have one of our devices in the room and it could foretell when an asthma attack is going to happen a lot of hours before this attack actually happens.
What happens if the microprocessor you put in, the wet chip that you put in, turns out to actually not become obsolete with time, but to learn and become better with time? It becomes an expert system.
Right? So the plasticity or the learning is built into the system from the get-go. It learns from you.
So your 20-year-old neural chip is actually better for self-driving your car than a new in silico chip.
To read and write information into singular neurons, it's a very, very powerful thing. In my mind, this is the next big thing. Now, it doesn't matter where that neuron is. Either it's inside the body or outside the body. If it's outside of the body, you could do computation with that, you could do sensing with that, you could do drug discovery with that, you could do diagnostics with that, and a lot of other things. Now, when that goes inside the body, the technology is the same. Right? It opens new doors in terms of sensory control, the integration of man and machine in that sense.
So imagine a world where all of us are able to have a prosthetic brain. Instead of just like prosthetic hips and arms, you can actually have a prosthetic brain. And that brain has the properties that for every second that passes, you can think for the equivalent of 35,000 years. And so problems that are really hard for humans to solve are trivially easy for you to understand. And not only that, but you can share thoughts telepathically with other people and view the world literally through other people's eyes.
Imagine you could have access to the sensory data of all sensors ever built and to unlimited processing power. What questions would you be asking yourself?
What we take to be reality is constrained by the details of our biology. We're marrying our biology to our technology, and that opens up what we're able to perceive.
How does that work in practice? That feeling can be transmitted essentially as a neural code. So people would have not just a Facebook connection that is characters, it's going to be the full sensory bandwidth.
I think the furthest future version of how what we're doing could impact education is like the Matrix, where you're able to load up some new piece of knowledge that you want and snap your fingers and suddenly you know how to speak fluent Mandarin or fly a helicopter.
I know Kung Fu.
Every discipline of science and engineering, electronics, physics, chemistry, materials, is starting to feed into our technology for mapping and repairing the circuitry of the brain.
The idea that I'm going to digitize a brain right now still has this black box in the middle of that process, which could be impossible. You know, the physics of consciousness. It could be magic.
In the end, all of this is using code. That means there's no reason we shouldn't be able to figure this out.
Can we really do computation with neurons? The answer to that is a clear yes. The details of doing that is what we are now working on.
Neurotechnology is changing the future of human intelligence, and each of us can determine how. So what kind of world will you help build?
Just what is it that you want to do?